Howdy folks, Mr. Reed here, and welcome to One More Question. So we're taking a look at horizontal and vertical translations, and this time what we're going to do is take an original graph and map it onto a new graph by using mapping notation. So what we're going to do is take something that's just a single translation for our function, and so we're going to rate this one at a mild question, so let's get to it. Alright folks, I already have a fair bit written down. Now we have our general form of g of x is equal to f onto x minus h plus k. So this only works for translations, of course. All we have are the h and the k parameters. And then the other stuff that I have written down there, I already have the 4 points that are a part of our original f of x function. So we have the negative 2 comma 4 point, the negative 1, 0, the 2, 1, and the 3, 5. What we're going to do is we're going to take a rule that we're going to come up with, a mapping rule, and this is going to allow us to come up with the set of 4 points that are associated with these 4 points. And since this is a piecewise function that's just made up of a bunch of straight lines, we can play connect the dots with these 4 points that we'll come up with, and we'll have the graph of our new function. So to start things off, let's talk about how to make a correct mapping notation or a mapping rule for this particular transformation. So we have any general x comma y point to start with is going to be changed, or it's going to map onto x, and then let's think about it for a second. The h is the horizontal parameter, and that horizontal parameter is going to move it side to side, so it affects just the x value. In this particular case, we have x minus 4 in the function that's above me right now. So that's the inside of the argument. So x minus 4 in the argument means that the h value, because it's x minus h, is a 4. So what does that 4 do? Well, it's going to move it 4 units to the right. How does that modify the x value? Well, a movement of 4 units to the right along a number line is the same thing as adding 4 to it. So it's going to take that x value and it's going to add that h value, which is 4, to what was already there. That's going to give me x plus 4 as the new x value, guaranteed every time, because with this particular translation, it's always going to be moving to the right 4 units, which always adds on that 4 to the x value. Since we have no other translations going on here, we actually have just y as the other part of the mapping rule. Whatever the y was before stays the y afterwards. So what we're going to be able to do is take these values and follow the rule. So it tells me to take my old x value and add 4 to it. So negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 2 plus 4 is 6. And 3 plus 4 is 7. So I did all the x's together. It doesn't really matter what order you decide to do things. And now I'm going to do the y's, which actually is leave it alone, leave it alone, leave it alone, and leave it alone. So we have a set of 4 new points. Those points are 2 comma 4, 3 comma 0, 6 comma 1, and 7 comma 5. Like I said before, since this is just a nice piecewise function that has linear pieces splitting up or connecting these points, we can map these 4 points and then play connect the dots. So let's go ahead and do that. So 2 comma 4 would bring us to right here, and then we have 3 comma 0, and then we have 6 comma 1. And then we have lastly 7 comma 5. So as I said, we play connect the dots. I'm going to just connect these with some straight lines. Now this thing kind of snaps to grid. I probably should try to get rid of that, but it looks okay. I could have done a better job with that first line. Maybe I'll just do it freehand next time. But this would be our g of x function. So it is slid over 4 units to the right. Now, you might say that this was a lot of work for something that was pretty obvious what to do from the get-go. You would say 4 units, right? Okay, so I just take all those points and slide them over 4 units. So 1, 2, 3, 4, point, 1, 2, 3, 4, point, 1, 2, 3, 4, point, and the last one as well. That's entirely true. So if you have a feel for that and you want to get this one done and out of the way really quickly, go for it. The only thing is, mapping notation is especially helpful when the when the function is either a little bit funny looking or there are a number of transformations going on all at once, or translations, and once we get into it, stretches and reflections, where it's a little harder to just visualize exactly what's happening to each point. But when it's only a single translation, pretty straightforward, and so feel free to answer the question any way you want. All right, so that's an introduction to mapping notation and how to draw a graph for a given transformation. Hope you found that useful. Like, subscribe, and thanks for spending your time here. Take care, folks.